So good evening to all of you. Once again, we will discuss the problems on super mesh for using the loop analysis method. He was given in the problem on question paper for the circuit shown in below figure A. Find the currents and voltages in all the branches using mesh analysis. Using mesh analysis, you are requested to calculate what is the current in all the branches. At the same time, you need to calculate the voltage across all the branches. So what we are going to do, we will first represent the notations A, B, C, D, E, F. That's all. First thing, observe the circuit properly. There is a current source exists between these two loops. So ultimately these two loops are, we used to call it as a super mesh. It is a super mesh. So given circuit, we have got a current source between these two loops. So these two loops are super mesh. Your wish, you can take this as I1, I2, I3, I1, I2, I3, or I3, I2, I3, I1. Your wish, however you want to take it. Okay. So now, I am going to take, this is my first loop current, and this is my second loop. This is I2, and this will be my I3 current. I3 current will be like this. This is my I3 current. Okay. Now, as I told you in my previous video, first of all, while solving the problems on super mesh analysis, observe properly the current source. You are requested to write the equation. You are supposed to write the equation for the first current source. Equation. See, he was given in this problem. So current source has been exist between B and E node. So the second current will be I2 will be like this, and the first current I1 will be like this. So the direction of the second loop current is coincidence with the direction of the current source. So we are going to take I2 positive value. So I2 minus I1 is equal to 5 amperes. So this is the first equation. See here, whatever the current source he was given in this problem. So here the direction of the second current is coincidence with the direction of the first current. Direction of the current source. So because direction of the current source. Therefore, we need to be take secondary current. Second loop current will be positive. I1 current is not coincidence with the direction of the current source. Because of that reason, we need to take negative value. ఇచ్చినటువంటి సర్క్యూట్ లో సెకండ్ కరెంట్ యొక్క డైరెక్షన్ అనేది కరెంట్ సోర్స్ యొక్క డైరెక్షన్ కి ఈక్వల్ అయింది, సేమ్ ఉంది. బికాస్ ఆఫ్ దట్ రీజన్ మనం ఏం చేస్తామంటే దీన్ని పాజిటివ్ గా తీసుకుంటాం. I1 అనేది డైరెక్షన్ కోఇన్సిడెన్స్ కాలేదు, సో దాన్ని మనం నెగిటివ్ గా తీసుకున్నాం. సో I2 minus I1 is equal to 5. దట్ ఈస్ ఈక్వేషన్ నెంబర్ 1. నెక్స్ట్ మనం ఏం చేయాలి? వాట్ వీ నీడ్ టు డూ ఫర్ ది నెక్స్ట్ స్టెప్, యూ నీడ్ టు అప్లై ది KVL to the super mesh for the super mesh of the two loops. So applying the KVL to the loop, A, B, C, D, E, F, A, B, C, D, E, F, A. You need to apply the KVL to this loop. So current entering is positive, leaving is negative. Current entering is positive, leaving is negative. Current entering is positive, leaving is negative. You are traveling from A to B. At this branch, AB branch, there are two currents are flowing. So what we are going to do, 1 into I1 minus I3. While writing the equation for the first loop, you should give the priority to the first loop. Okay, 1 into I1 minus I3. Next, current entering is positive, leaving is negative. BC branch, two currents are there. One is I2 current, another one is I3 current. So 3 times of I2, 3 times of I2 minus I3. You are moving from C to D plus 0.25 times of I2. D to E nothing is there, U to F nothing is there, but F to A, while you are traveling from F to A, 8 is equal to 0. So I1 minus I3 plus 3I2 minus 3I3 plus 0.25 I2 is equal to 8. So I1, okay, next term will be the I2 term. So 3 times of I2, okay, 3I2, okay, 3I2. Next 3.25 I2. So we are having one more here, 0.25 I2 is equal to 8. Okay, so then this value will be 3.25 I2, 3.25 I2. Okay, 3I2 plus 0.25 I2. Next, minus I3 minus 3I3 will be minus 4I3 is equal to 8. So this is your equation number 2. Okay, this is your equation number 2. Next, what we need to do? You need to apply the KVL to the third loop. Applying KVL. Applying KVL to the loop. Which loop? ACBA. ACBA. So you are traveling from A to C. Current entering is positive, leading is negative. 2 times of I3, 2 times of I3. C to B. So plus 3 times of I3 minus I2. Next, 1 time of I1 minus I3 minus 1 time 1 into I3 minus I1 is equal to 0. So you can able to write this equation 2I3 plus 3I3 minus 3I2 plus I3 minus I1 is equal to 0 minus I1. So minus 3I2 minus 3I2. So 2 plus 3 will be 5, 5 plus 1 will be the 6I3. 6I3 is equal to 0. So this is equation number 3. So solving equation 1, 2 and 3, you are going to get what is the value of I1, what is the value of I2, what is the value of I3. So taking the calculator, you can easily solve this solution. That is I1 value 1.105 amperes. Next, I2 value 6.105 amperes. I3 value 3.2368 amperes. This is what the values of the current. Now, what you need to do? You need to find out the current in all the branches. అతను ఏమన్నాడు ప్రాబ్లంలో మనం కరెంట్ ఇన్ ఆల్ ది బ్రాంచెస్ మనం క్యాల్కులేట్ చేయాలి. హౌ టు ఫైండ్ అవుట్? సో వీఆర్ హ్యావింగ్ ది బ్రాంచ్ కరెంట్ AB. సో యూ నీడ్ టు బి రైట్ ఇట్ యాజ్ కరెంట్ త్రూ AB, కరెంట్ త్రూ ది AB. దీన్ని మనం IAB అంటాం, IAB. సో ఇక్కడ 2 కరెంట్స్ ఆర్ ఫ్లోయింగ్. One is I1, another one is I3. How to find out which one we need to take, whether I1 minus I3 or I3 minus I1. I1 minus I3 తీసుకోవాలా లేదా I3 minus I1 తీసుకోవాలా, ఎలా తీసుకోవాలా అంటే అప్పుడు మనం let us say whatever the values you have got, just kindly observe that one. So whichever the larger that value you need to be take it. Okay, so ఇక్కడ I1 I3 లో I3 is the larger than the I1. So you need to be write it as I3 minus I1. So I3 minus I1 means 3.2368 minus 1.105. If you solve this, probably you are going to get this value 2.1316 amperes. 1316 amperes. Next, what we need to do? Current through the branch BC. Current through the branch BC. So you can write it as IBC. So again you are having 2 currents are flowing, I3 and I2. Which is higher? I2 is higher than the I1. So because of that reason, you can able to take I2 minus I1. So I2 is 6.105 minus I1 is 1.105. So if you solve this, probably you are going to get this value. Okay, you are going to get this value I2 minus I1, right? I2 minus I1. So I2 minus I1 sorry, I2 minus I3. I2 minus I3. So while you are solving the I2 minus I3, so this value will be 3.2368. So you are going to get this value 2.8682 amperes. 2.8682 amperes. Next, current through the branch AC. Current through the branch AC. So AC, you are having IAC is equal to which current is flowing? I3 current. I3 current will be 3.2368 amperes. Okay. At the same time, we are having current through the branch CD. Current through the branch CD. That is ICD is equal to which current is flowing here? I2 current. So I2 is equal to how much? 6.105 amperes. 6.105 amperes. Now what you need to find out? So current through the branch AB is over, current through the branch BC is over, current through the branch AC is over, current through the branch CD is over. Now what you need to find out? Voltage across branch AB. Voltage across branch voltage across branch AB. So voltage across the branch AB, nothing but VAB. V is equal to I into R. So IAB multiplied with RAB. So what is IAB? IAB is 2.1316 multiplied with RAB. Which branch is there here? 1. So you are going to get 2.1316 volt. 2.1316 volt. Next, voltage across branch. Which branch? BC. We need to take BC. So VBC is equal to IBC multiplied with RBC. What is IBC? We have got IBC value 2.8682. 2.8682 multiplied with RBC. Which resistance is there here? RBC resistance is 3 ohm. So multiply with this. VBC is equal to IBC into RBC. Probably you are going to get 8.604. 8.604 volts. Next, voltage across the branch CD. Voltage across the branch. CD. What is there here? VCD is equal to ICD multiplied with RCD. ICD, current through the branch. ICD just now we have calculated. That is I2 6.105 multiplied with RCD. What is the resistance in RCD branch? 0.25. So you are going to get probably 1.5263 volts. Next, voltage across the branch AC. What is the voltage across the branch AC? Voltage across the branch AC, that is VAC is equal to IAC multiplied with RAC. What is IAC? So you are having the 3.2368 multiplied with RAC. What is the resistance in RAC? That is 2 ohm. So if you do this, 6.4736 volts. So this is how you need to calculate what is the voltage across the branch AB, VAB, voltage across the branch BC. VBC is equal to IBC into R, because V is equal to I into R. Which branch? VBC branch. What is the current? IBC. What is the resistance? RBC. So this is how you need to calculate the problems on Supermesh. Thank you for watching this video.